This is the intro video for AP Calculus BC, section 5.2. In our previous video and class, we looked at the derivative of ln of x, and so now we're going to be looking at integrals that will lead back to that. So let's take a look here at our couple of rules here, and we'll do an example. The first one says integral of 1 over x dx. The hope here would be that you would recognize that 1 over x is the derivative of ln of x, and so the integral of 1 over x would just be reversing that process. And so what we'd write here is ln, and then we'll talk a little bit more about this notation as we go. Ln of absolute value of x plus c is what we would write there. Like I said, don't worry too much about the absolute value right now as to why it's there. We'll continue to develop that out as we go. One note here, certainly seeing a lot of people look at that 1 over x and think, well, hey, let me flip that up and get x to the negative 1, and then just treat it as a power rule, which is a viable thought, except when you try to actually do it, then it's not so viable. If you add 1 to the exponent, you get that, which is not a big deal, but then you have to divide by that new exponent. So you end up with x to the 0 over 0. Of course, we cannot divide by 0, and so that would not work. So if you ever find yourself doing the power rule with an integral and dividing by 0, it's pretty likely you should go back and consider ln as your best option. Okay, and then of course the other one here, integral of u prime over u. This would be if we're dealing with a composite situation. And the idea is that the u prime needs to be the right u prime. We might have to make an adjustment like we've done in the past. It might be a mistake that we need to fix, and we can fix that for sure. But as long as this is the perfect u prime over u pattern, then we can say that this is equal to ln of absolute value of u plus c. Okay, so our example here, number 1, we'll do more of these when we're in class next time. But it's the integral of a fraction, and as we go throughout all of our fractions, you're going to find that I'm going to encourage you to consider natural log first. And so as we think about this natural log idea, we want to ask ourselves, is the derivative of the denominator the numerator? And so the denominator is x cubed plus x. The derivative of that is 3x squared plus 1. And you can see that the numerator is, in fact, exactly the derivative of the denominator. And so this perfectly fits the natural log pattern that we just were talking about. And so we can say then that this antiderivative is ln of that denominator plus c. When we get to class, we'll look at some of these where some adjustments and such are needed. But for now, that one worked out pretty nicely. Hope that's good for you. See you in class.